Good afternoon, everybody.
Afternoon, sir.
Anybody did the paper?
Yes, sir.
Yes, sir.
Okay, so you didn't send it to me. Let me see what is what. All right, so you know it is. Those of you who did it will benefit from this exercise because you will learn from your mistakes. Those of you who didn't do it, you still can get some benefit if you go and do it after this session. I hear everything right this morning. I'm hearing everything. All right, so let's do this. Hold on a second. Hold on a second, guys. Let's check something. I'm trying to record a session. Let's check. Okay. All right. All right, so we're going to do people from the back. Huh? Yeah, good afternoon. Good afternoon. I'm trying to mute this thing. All right. We're going to start at number 1. And let's work our way around. I don't know if I'm going to do the entire paper today. All right. We have another session tomorrow. Depending on how far we reach today, I might send another paper for tomorrow. All right. So this is the January 2020 paper, as you can see. We're going to start at number 1, which is telling us to use a calculator or otherwise to work this out. Hold on a second, this thing disturbing. Just give me a second. Okay, but I'm mute it. All right, let's bring up the calculator. All right, so it's just a matter of typing this in the calculator exactly as it is right here. All right, so that's usually you need to get one of those textbook display calculators. All right, so the first thing here is a mixed number, which is that mixed number 4 1/5. Then we're multiplying by a fraction, a third. And we're subtracting a mixed number, 1 1/4. And they want the exact value. And 0.15 to see it as a fraction. This will be it. All right, so this will be equal to 3/20. Want to get that?
Yes, sir.
Yes, sir.
All right. All right, next one is this. Do the same thing. Type it in the calculator. And that one be a fraction. And it is 4.1 minus, wait, minus 1.25 squared. And you're dividing that by 0.005. Make sure you type it in exactly as it is there. Don't put the extra zero or don't put any zero less. Type it in exactly as you see it there. And this works out to 507.5. That's that. Next question.
Sir, question.
Yes.
You wouldn't be marked down for rounding it. You can just have the rounded number.
No, don't round it. Question say exact. Look, exact.
Okay.
And I put the exact in bold capital letters for you. So I don't want to adjust it in any way, shape, or form. The exact value they want. Okay? All right. So that's what happens when you do the work and you learn from your mistakes. Very good. All right, let's go. They don't want us to do this one now. Another calculation question. It says a stadium currently has seating capacity for 15,400. All right. Calculate the number of persons in the stadium when 75% of the seats are occupied. So 75% of this. So 75 over 100 multiplied by 15.4. That is it. 75% is same as 0.75. So we can put that 0.75 times 15,400. That is equal to 11550. That is it. All right, next one. Says the stadium is to be renovated with new seating capacity. This is going to be the new seating capacity. Now remember, the original seating capacity is this one. So it's an increase from this to that. All right. And it says, after the renovation, what is the percentage increase? So the percentage increase is the increase over the original amount multiplied by 100. Remember, you take the percentage of the original amount, and it's the increase divided by the original amount. So what is the increase? So the increase is 20,790 minus the original amount, which was this 15,400. That represents the increase divided by the original amount. This is the original amount. So you divide by the original amount. You multiply that by 100. That gives it a percentage increase, which is equal to. I don't need to calculate the actual value of the increase. I don't need the actual value. All right. I tell you, when you're doing these questions, you try to use a calculator one time. All right. The minimum number of times you can use a calculator is the better. All right. So you don't want to be calculating this. You don't need that figure, the increase figure. You don't need it. You don't need to work out what it is. All right. You're gonna get any extra mark for working this out. Just that figure there. So let's go. So it is a fraction, and it's 20,790. You subtract the original amount 15,400. That is the increase I have in the numerator there. And divided by the original amount. Multiply that by 100. That's 35%. You can see it's 0.35 is that's what happened. Thing went back. Anyway, it's 35%. 35%. But I got that?
Yes, sir.
Okay, good.
Very nice.
Yes.
So somebody said something?
Your whiteboard is down.
Yes, sir. Yes, sir.
Oh, hold on. Hold on a second. Okay, it's lost connection a bit. . Can I see it now again?
Yes.
All right. So it's 35%. 35%. All right. So the calculation just came off the screen. Let me just write it back. What happened? So working out again. Just gotta type in this in the calculator, which is 20,790 minus 15,400 over 15,400 times 100. With that percent, 35%. All right, next part. A neon light flashes 5 times in 10 seconds. It's a ratio question. Show that the number of flashes, show that the light flashes this number of times in a day. So we can start out at the ratio and multiply this 10 seconds all the way up to a day, which is 24 hours. I'm going to set it out like this. So the number of times or number of flashes to the time. I'm going to say, okay, it's 5 flashes to 10 seconds. I want my 10 seconds to become a minute. So I multiply it by 6 because I want to become 60 seconds. I'm going to multiply by, remember in a ratio, you can multiply a ratio or divide a ratio by any constant value or any constant unit. Any unit or any value. So I want this side to become 1 day. I'm going to carry it up to a minute first. Then I'm carrying it up to an hour. And then I'm going to carry it up to a day. So to get it to become a minute, I have to multiply by 6 because 60 seconds make a minute. So I multiply by 6, multiply the entire ratio by 6. All right, so multiply this side by 6, it becomes 30. Multiply this by 6, it becomes 60 seconds, which is actually 1 minute. And to get it to 1 hour, I need to multiply by 60 because 60 minutes make 1 hour. So I'm going to multiply by 60 now. So multiply this by 60. 6 is 18, sorry. 18,002. This becomes now 60 minutes. Multiply this by 60, so I get 60 minutes. 60 minutes is actually 1 hour. Putting it there. Then to get a day, I need to multiply now by 24. 24 is make a day. So I'm now going to multiply by 24 to bring the time to a day. So multiply this by 24, and that's where we should see the number of flashes now. So it's 1800 times 24. Voila, there we go. This becomes 43,200 to 24 hours, which is 1 day. All right, and that's it. That's the answer right there. All right, 24, 43, 200 flashes in 1 day. But I go with that.
Yes.
Shown.
Yes, sir.
Or we can say shown. Because a proof. So that was shown. All right, question 1 done. Let's go. Number 2. Told it to the number 2 as well. All right, I don't think I need to calculate anymore. All right, so here now, we need to factorize completely. Meaning, when you factorize, you have to factorize each part so that there's no further factorization that is possible. All right, so here now I see 2 terms right here in this one. And I recognize h as a common factor. So I'm going to factorize away the h. So this becomes equal to h into h out of this leaves me with 5h. H out of this leaves me with negative 12g. Then I inspect here to see if it can be factorized any further, and no. There's no common factor left. So that is it. But good with that?
Yes, sir.
Yes, sir.
All right, good. Then here now is our quadratic. And I like quadratics when there's a prime coefficient either here or there. That's not a prime number, there's one here. And so you can literally factorize this by almost like a trial and error observation method. We have the process way that we can use, and I'll show you. But you can also, you have to learn this way of doing it quickly. All right. So let's set it up. 1 second. All right. So we know that the factors of the 2x, I'm just going to do the quick way first, right? And show you. So the factors of this 2x squared can only be 2x and x. And so you need factors of this minus 6 to go here and here now. And remember that the far product and the near product must give you this middle term. All right, so you can literally use a trial and error method. And sometimes you can think ahead and see what it would be. Right, because the factors of the 6, right? If I put the 1 and the 6 here, then the far product is 12x. 12x minus 1x cannot give me this. Minus or plus, it doesn't matter. Cannot give me a minus 1x in the middle there. So I know that I can use 1 and 6 that way. If I switch them around and put the 6 here and the 1 here, still I won't get it because this is 2x and this is 6x. 6x here, 2x here. If I subtract them or I add them, I cannot get a negative 1x there. So cannot be 1 and 6. Factors of the 6 cannot be 1 and 6. So the only factors you have left with the factors of as factors of 6 will be 2 and 3. Suppose I say, okay, let me put the 2 here and the 3 here. And this product is 2x, and this product is 6x. The difference between 6x and 2x is 4x. My middle term is just a negative 1x, so I can't use it that way. So, okay, so let me switch it around and put the 3 here and the 2 here. Then the far product is 4x and the near product is 3x. So yes, the difference between these two is the middle term, which is 1x. And how do I know that I need the difference? I know that I need the difference because my last term is negative. When my first term is a positive squared, or a positive squared coefficient, a positive coefficient of a squared term, right? Which is normally the case. Then this term here, sign of this term tells me, because it is negative now, that the signs in the bracket are different. And also means that it is the difference between the far product and the near product that gives me the middle term. All right. I also know, but because this is negative, one sign, there were two different signs in the bracket. One will be positive and one will be negative. All right. So if I try the minus here and the plus here, for example, this would be 3x and this would be minus 4x. 3x minus 4x is actually negative x, which is the middle term. So it means that they are positioned the right way, and those are the two factors. If I put the negative the other way around, like if I put them, the negative and the positive, if I put the positive here and the negative here, then this would be minus 3x, this would be positive 4x. But positive 4x and minus 3x will give me a positive x, but my middle term is a negative x. I know that I can't leave it that way. All right, so this is it. They are supposed to be this way. The positive here, the minus here, and the plus there. Far product is minus 4x, near product is 3x, and they add to give me the middle coefficient. All right, so that is like a quick shortcut. I'm taking so many steps because I'm trying to explain it. But with practice, you'll be able to literally look at this, and be able to just write that with practice. But let's look at the long way now, right? Let's look at the long way. So we know that these are the answers. These are the factors right here. Let's look at the process way now. All right, so what is the process? The process is that you're trying to split this middle term and you try to expand this out into 4 terms. So you can factorize it by parts. All right. All right, so what's the process? Multiply the 2n coefficients, 2 and a negative 6. So multiply 2 and negative 6, that is equal to negative 12. Then I'm searching for factors of negative 12 that gives me the middle coefficient. Middle coefficient is actually negative 1, so they're not going to show the 1 there. So I'm going to put the negative 1 here. So I want factors of this negative 12 that add to negative 1. Since I want factors of a negative number, one factor will be positive and one will be negative. Since I want the sum to be negative, I use the larger factor. Give the larger factor the same sign as this. Now let's say you can look at it and see that the factors that you want really right now is 3 and 4. Those are the factors in number. Let's say you don't see. You can go down the list of factors and try. So the first 2 factors of 12 were 1 and 12. I have to give the larger one the same sign as this. So I'll give it this one the negative, the 12, this one the positive. When I add these 2, I'm getting negative 11, but I want negative 1. So this is not the 2. That's not the combination I want. So the next 2 factors of the 12 will be 2 and 6. I have to give the larger one again the sign of the middle term that I want, or the middle coefficient. So I'm going to make the larger one negative, smaller one positive. But 2 and negative 6, they add to negative 4. My middle term is not negative 4, so I don't want that either. The next 2 factors of 12 will be 3 and 4. With the larger one, the same sign as the sum that I want. That's the middle coefficient that I want. So minus, plus. Then now 3 and minus 4, when you add them, you get negative 1. So that's it. So it means that this negative 1x, I'm going to split it using these 2 factors, 3x and negative 4x. You can put the negative 4x in front and put it as negative 4x plus 3x. All right, so that's how we're going to split that out. All right, so I'm ready to split this out. And so this 2x squared remains, it's 2x squared. Then the minus x, as I said, I split it out into this. I'm going to put the negative 4x first, plus the 3x. See, so the minus 4x comes from this factor, and the plus 3x comes from this factor, and then the negative 6 is coming back here. I always kind of check that what you split the middle term into would give you this back. Always kind of do that check in case you make a mistake with the signs or something. Always check that what you split it out into would give you back that middle term. All right, which they would in this case. And why did I put the minus 4? Why didn't I write it as 3x minus 4x? Would work this way still, you know. But I want to set it out nicely because the 4x will factorize nicely with the 2x squared. And that's the only reason why I put this here. Similarly, this 3x will factorize nicely with that negative 6. But if I put it as 3x minus 4x, no problem. All right, we get the same 2 factors in the end. So now I'm going to look for the highest common factor in these first 2 terms. The highest common factor, not just a common factor, the highest common factor you want, which is 2x. So I'm factorizing 2x out of these 2 terms. 2x out of this leaves me with an x. 2x out of this leaves me with negative 2. Remember, you must have the same thing factored out of these 2 terms. You want the same thing in the bracket. What I normally do is write it back first, the x minus 2. And then inside here, must have plus a value or minus a value here. Cannot just put a value, plus a value or minus a value. How do I know what it is? I can know what should go there by dividing this by this. The negative 6 divided by the negative 2 is going to give me a positive 3. Or I can divide this by this. Still, I'm going to get a positive 3. I divide those. So I'm going to get a positive 3 right here. If you're not sure, you can double check it by just expanding this again. 3x times x is 3 times x, sorry, 3x squared, 3x. 3 times negative 2 is negative 6. So you can do a little double check if you're not sure. Then x minus 2 is a common factor, and they are being multiplied by that 2x plus 3. So I'm going to factorize 2x plus 3 and x minus 2. And that is the importance of making sure that you have a sign out here, whether it's a positive or negative. But that is what ends up in this bracket here. So you know whether it's a plus or minus should go there. All right, that's why you must put a plus or minus value in between there each time. Practice it the same way every time and you'll be good. So you see we have gotten the same two factors here, guys. Same two factors. I did it the shortcut way. But you want to really get these 2 marks without having to do all of this work. All right, and CSEC like to give you factorization quadratic with prime coefficients. If they give you 2 prime coefficients, even easier, but this time it's just 1 prime coefficient that they gave you. The 2 is a prime number. So the only factors of 2x squared is 2x and x. So you already know these 2 values. So like you're halfway there. All right, so I needed to practice it that way. I want to do the mathematics the easy way every time. All right, that is it. Everybody good?
Yes, sir.
All right, we don't want to do so much work. We don't want to do all of this work for 2 marks. When you can do it by looking, just make sure you factorize it properly. And if you're not sure, you expand this again to see if when you expand it, you get in this back. Just do a quick expansion in your head. All right, check it. Remember, the first product of the first 2 values give you this. The product of the second 2 values, the 3 and the negative 2, gives you this negative 6. And the middle term is obtained by adding the far product to the near product. Those give it the middle term. All right, with that knowledge, then you can factorize quickly. You need to practice it, practice it. All right, that is that. Next question. They want us to solve. The word solve in mathematics means find the unknown quantity, find the value of the unknown quantity. In other words, make R the subject, R alone. You want to find what value of R. What's the value of R that will make this equation, that will satisfy that equation? So it's basically solving for R. So you need to expand and get R alone as a subject. You need to expand this side and transpose to make R alone the subject. So this side remains R plus 3 equals, I'm going to expand this side. It will become 3R minus 15. I'm going to take this R and transpose over here and subtract it. I want to keep the R term positive. Take this 15, transpose it over here and add it. So I'm going to get 15 plus 3 equals 3R minus R. So this negative 15 came on this side to become a positive 15. I need this to be a R, not a 2. And this positive R came on this side and became a negative R. And so this 3R minus R is 2R. And this 15 and 3 is 18. I need to just divide both sides by 2, leave R alone as a subject. Or I can say divide this 2 under here. And so R will be equal to 18 over 2, which is 9. So the R is equal to 9. I can just check it back in and put 9 here and 9 here and see if it works, right? 9 is going to give me 12. If I put 9 here, I'm going to get 12 again because 9 minus 5 is 4. Inside is going to become a 4. 3 4 is 12. So you know that the answer is correct. So simple question like this, we can check and make sure your answer is correct. You do it. All right, quick and fast. All right, next one. Make K the subject. This is the K. So basically, I want to transpose everything away from this K. First, we're going to move this 3T into over here and subtract it. So I'm going to get 2A minus 3T equals pi K squared. I need to move this pi by dividing both sides by pi. For a shortcut, we say since the pi here is multiplying, I'm going to divide it under here. Any way you want to look at it, K squared is going to become 2A minus 3T all over pi. Then together we have this square, we square root both sides. So we square root this side and square root that side. Right? And the square root cancels the square here. All right, you can leave this on the paper if you want, right? And then you show that the k, this becomes just k, is now equal to all of this, so the square root of 2a minus 3t. So a little better. Divided by pi, everything under the square root sign. But I go with that. That's my answer.
Yes, sir.
All right, good. Nice and easy, eh? Nice and easy. You can do it in the class, you can do it in the exam. Remember, this one says, a farmer plants 2 crops, potatoes and corn, and he's placing them on a 10-acre piece of land. So the total land space is 10 acre, 10, right? It says the number of acres of corn, C, number of acres of corn is C, must be at least means greater than or equal to, at least. If you must have at least $10 to buy something, it means that you must have $10 or more, at least. Means that amount or more. Must have at least twice the number of acres of potato, which is P. Twice number of, it's 2P. Number of acres of corn is C. That's inequality right there now. But I want 2 inequalities. The first inequality is wrapped up in the statement that the land space is 10 acres. So the total acreage of the corn and the potato must be 10 or less. You can't plant more than the land space that you have. All right, so 2 inequalities that one. So the first one is based on the fact that the total land space is 10 acres. So the number of acres of corn, C, plus the number of acres of potato, P, has to be less than or equal to 10. Because the total land space you have is 10. The second one is in this statement that we wrote out like this. It is that the C, number of acres of corn, must be at least greater than or equal to twice, 2 times, number of acres of potatoes. That's it. So these are the 2 inequalities, 1 and 2. That's what I want to write there. Very good?
Yes, sir.
All right, good. Let's go. I don't want us to do anything else. So I say we're to the 382, right? It's just to read something of this shape. One of the polygons later on in January. All right, but this one is asking us complete the following statement. This prism, that's a prism. How many faces? What are the faces? But I can't tell me what are the faces. We don't count them, just tell me what they are. What is a face?
Face at the surface.
Huh?
I would say it's the surface.
A what?
The surface.
A flat surface on this on the shape, right? So this kind of how many faces, how many flat surfaces. So these are the flat surfaces. Like there's one on top here. There's one on the side here.
Yes, sir.
There's another one here. There's one beneath here. There's one on this edge right here, and there's one over there, right? And there's also 2 ends. There's one at this end, and there's one at the back. Those are also faces, right? So around the side, there are 1, 2, 3, 4 on the base, 5, 6, and then the 2 ends. So there are 8 faces. What can I get with that?
Yes, sir.
You know, somebody actually came up with a formula to know the relationship between the number of faces, edges, and vertices of shapes. There's some formula that they use, but I don't get into that when you can just count it. And so what are the edges now? Somebody tell me what are the edges?
18.
No, don't tell me how many. Tell me what is an edge.
13 faces meet.
Right. It's basically like the line joining 2 faces, right? So So we're talking about like this line, this line, this line, this one, this one, and that one. And you have these around here as well. Right? So if you count them around the side, there are 1, 2, 3, 4, 5, 6 around the side. And then on the ends, so you have 6 around the side, plus you have 1, 2, 3, 4, 5, 6. Plus you have 6 over here again. 1, 2, 3, 4, 5, 6. 18 is correct. All right. And then now what are the vertices? What's a vertex?
When the face and the edges meet.
I would say is where the edges meet. They're like points. Like where there are points, like here. Like here, and here, and here, and there, and there, there, there. So they're like where the edges meet, right? How many of them? That 12?
Yes, sir.
12. So they're like points. Those are vertices. And that was that. 3 marks, 1 for each. Hope everybody got one right. Believe me, people get these things wrong. We'll do this at another time. We'll do the topic of geometry construction. Here we come to a transformation. This one says quadrilateral PQRS and P prime Q prime R prime are shown. So this one is the object. This one is the image. And you can know the answer for this question by just looking at it. So it's obvious that it's an enlargement because this enlarged to this. Because this is the object, this is the image. I know that this is the image because the prime is on it. Right? The prime is on those vertices. What's the scale factor of the enlargement? It is 3. 1 unit is 3. But this side is 1 unit and it has been enlarged to 3 units. So it's a multiplier by 3. All right, so I know the scale factor is a 3. I also know that it's positive because the image and the object pointing in the same direction. So for example, PS is pointing this way on the object and PS is pointing the same way on the image. Once they are pointing in the same direction, right, then the scale factor is positive. So I know it's a positive 3. So scale factors, enlargement has 2 components. There's a scale factor and a center. So what we don't know yet is a center. Center is the easiest thing to find. You find the center by joining corresponding points, like for example, Q and Q prime. So you join these with a straight line, extend it back, and you join these two, like you join like P prime and P, extend it back. And then now it is showing me here as a center. I can check it because remember the scale factor also affects the distance from the center. So what do I mean? So for example, the distance to P from this center is 2 units right here. It's 2 units. If the scale factor is 3, then the distance from the center out to P prime must be multiplied by 2 and become 6, multiplied by 3, sorry, and become 6 units. So you can check that. So this is 2 units to P. If the scale factor is 3 and this is the correct center, we know the scale factor is 3, then this should be 6 units. 2 times 3. I multiply the 3 by the 2. That's 2, 4, 6. So I can accept that as my center, but the scale factor works on that as well. So basically, I'm good to go. I know everything about it and I don't answer the question yet. Don't even read the question yet, but I know the answers already. It says, write down the mathematical name for the quadrilateral. That's a trapezium, right? It has 1 pair of parallel sides. It's a trapezium. That's a trapezium. Next one. PQRS is mapped onto P prime, Q prime, R prime by an enlargement with a scale factor of K, which you know is 3, about a center AB, which you know is this point here. That point is what? Let's look at scale properly. That's -1, -2, -3. So this is -4. And then in terms of the y, this is 1, 2, 3. So this is actually the point -4, 1. This point is -4, 1. This point, the center point. When the scale factor is 3. So I can answer everything down here now. All right. It says using the diagram, determine the value of A, B, and C. See here now, the K is equal to 3. And the center point AB is actually a center point -4, 1. So since I want to state these values, we can go further and say A is -4 and the P is +1 and the K is 3. Those are my answers. But the question asks us for these values. I'm making sure that I state them explicitly here. But I go to that.
Yes, sir.
Yes, sir.
Nice, easy question. All right, let's go. Next one. Function number 4. This question gives us this function. And it wants us to calculate f of 4 plus f of -4. Now, so it means that I'm going to plug the 4 in the f function, and you're going to plug -4 in there as well. Right? They're basically going to eliminate each other, but let's work it out still. So this becomes equal to the f of 4 first. I'm going to plug the 4 there. It's going to become 2 times 4 plus 7 over 5. I'm going to add, I plug the -4 in there now to get the f of -4, which becomes 2 times -4 plus 7 over 5. While you're adding these, and the denominator is already the same, mute the mic, please, mute the mic. Then I'm adding up the numerator. I'm putting everything over the common denominator of 5. So this is going to give me an 8, and it's going to give me a -8. So they eliminate each other. And so I'll have this 7 and this 7, 14. That's the answer, 14 over 5. But I good with that?
Yes, sir.
Yes,
All right, good. Next one wants us to calculate the value of x if f of x is equal to 9. What we're going to do, we're going to put f of x equal to 9 and solve. All right, what is f of x? Let's remind ourselves, it's 2x plus 7 over 5. So here, we're going to put 2x plus 7 over 5 equals 9. We're solving for x, transposing everything away from the x. We'll multiply the 5 first. I'm going to get 2x plus 7 equals 9 times 5 is 45. Then we're going to subtract the 7. We're going to get 2x equals 45 minus 7. How much is that? How much is that? 30 how much?
39.
39?
No.
I'm correct. 38. Subtract 5 first, you get 40, and then subtract 2 more, you get 38,
38.
right?
Yes.
Then we're going to divide by the 2. Divide both sides by 2. We're going to get 19. So the x is going to be equal to 19. What good with that?
Yes, sir.
This
Yes,
simply means, see this? The x is 19, you know? The x right here is 19, you know? So this means we can write i.e. f of 19 is equal to 9. So this, why did I write that? Because it becomes useful in this part of the question, which is now asking us. It says hence or otherwise. Hence is always easier because you're using the result from here, which is to recognize that if f of x equals 9 and you get x equals 19, it therefore means that f of 19 is 9. Now they want you to find f of negative, f to the minus 1 of 9. So starting with this statement, we have f of 19 equals 9. We're doing it the hence method. Always easier, quicker. If f of 19 equals 9, I want f to the minus 1 of 9. Like it taking f to the minus 1 on this side. So 19 becomes f to the minus 1 of 9. That's the answer. 19. Therefore, f to the minus 1 of 9 is equal to 19. So I give 1 mark for it. I can be done fairly quickly. But understand that?
Yes, sir.
All right. We're not going to do it any other way. Any other way is like a cardinal sin to do it any other way. It's only 1 mark for it. You're going to do it the easy way, which is the nth way. All right. Just recognize that if f of x equals 9, and I get x equals 19, it means that f of 19 is 9. So it means that 19 is mapped onto 9 with the function f. So f to the minus 1 of the 9 is taking it back to the 19. All right. You're reversing the mapping. That is that. So that size 19 here as well. Boom, bang, boom, bang. All right. So here now. Nice. Quadrant geometry. Question says the graph below shows two straight lines L1 and L2. I like this question because you can get everything you want off the graph. It's there. Minimum calculation needed. You can literally get everything you want off the graph. It says L1 intersects x-axis at 4, 0. It's right here. And the y-axis at 0, 2. Those 2 points. All right. That's line 1. This is line 1. This one is line 1. And then line 2 now is this one. And it says it intersects the x and y axis at 1.50. That's here. And 0, -3 is here. All right. So they're giving all that information. Might not even you need it. Right? I'm going to do it the easy way. It says determine the equation of line 1. Remember, you have the graph in front of you, and you don't have to go through any big calculation. So for line 1, which is this one, 2 things you need. You need a gradient and a point. You need a gradient of line 1, not the point. You need a y-axis intercept. Y-axis intercept clearly is 2, so you already know the c is equal to 2. What is the gradient? You can get the gradient by just going on the graph and doing rise and run. Look at this graph now. Remember, going from left to right, you're sloping downwards. So you know right away the gradient is negative. To go from left to right along the line, you're going downwards, so the gradient is negative. We're going to get the gradient. I'm going to choose 2 points, like for example here and here. Count the rise and count the run to go from here to here. Remember, you're going from left to right. What is the rise? To go from here to here. You come down 1 unit. See, this is 1 unit from 5 to 4. You're going down 1 unit, so it's a rise of -1. -1. The rise is -1. And then you run this way, 2 units, see, between -6 and -4. That's a run of 2 units. So the gradient of line 1 is rise over run, -1 over 2. I'm leaving this on the paper. So the examiner see where I got this from that I'm going to put here. -1 over 2. So my equation is y equals m1x plus c. I can call it c1 as well. Since I'm talking about line 1, let's call it c1. The c is where it crosses the y-axis. I'm not going to do any big long calculation when all information is there in front of me. So it's y equals -1/2 x plus 2. Done. That's it. Simple as that. The graph is there. Pull information off the graph. All right. Next one. It says, what is the gradient of line 2? Given that they are perpendicular. You can get the gradient from the graph as well, you know. All right. So I can look at the graph and get the gradient of line 2 as well. But given that it's perpendicular, let's confirm what it is. So again, I can choose 2 points on line 2. Any 2 points, like this one and this one. This time, if I go from left to right along the line, I'm going up. So the gradient is positive. I'm going to use these 2 points. Going from left to right this way, from here to here. I have to rise, count the rise first, 2 units. From 3 up to 5, that's a rise of 2 units. So I rise 2 units. Then I go this way, run. That's a positive run. So when I go up, the rise is positive. Over here, the rise was negative because we had to come down, right? That's why the rise was negative. Here, I have to go up, so the rise is positive. The run is 1 unit. See, from 3 to 4, this way, 1 unit. So I'm running 1 unit. So the gradient of line 2 is a rise of 2 over a run of 1. 2 over 1, which is 2. So the answer is 2. Gradient of line 2 is 2. But down here, the way our question is phrased, because I said, given that it is perpendicular, right? Given that it is perpendicular. So it looks as if they want us to use this. Gradient of line 2 is minus 1 over the gradient of line 1. Because it spoke about being perpendicular. Remember when the lines are perpendicular, they have negative reciprocal gradient. So gradient of line 2 is going to be equal to minus 1 over the gradient of line 1. All right, we know the answer is 2, you know. That's a gradient, you know. We can literally just write it down here. But I don't want to get it off the graph because it's as if they are leading us to use this method. But that is perpendicular to line 1. What's gradient of line 1 again? It was negative a half. So this calculation is obtained by flipping this and changing the sign. That's how it will become a 2. Flip the negative a half, becomes a negative 2 over 1 and change the sign to 2 over 1. Or if you like, you can put the negative a half under here and it will become minus 1 over minus a half. The negatives cancel, and to divide by a half is to multiply by 2. And so it will become a 2. Whichever way you want to look at it, that is the answer. 2. All right, I think if you get it off the graph as I did here, they would say give it the marks, right? But I just want to show them this simply because they mentioned this perpendicular property. All right, so that is that 1 mark for it. Beautiful. Done. Everybody good with that?
Yes, sir.
Yes, sir.
Good. Let's move to the next question. So the next question I gave you, this is a statistics. We don't know the topic yet. So skipping over this for now. I'm skipping over this one, which is our reasoning logic question. You notice that we're doing the majority of the paper now. So we're gonna far in the syllabus, right? We're doing a good majority of the paper now. This question gives us this diagram. It's a tricks question. It says diagram below not drawn to scale. So triangle MNP, in which angle MPN and angle PMN equal 52 degrees. That's these two. We don't do this topic yet, you know. We don't do polygons and so on. But this becomes an isosceles triangle. These two sides, these two angles are equal. So if those two angles are equal, then this side, which is opposite that angle, means that that side opposite this angle also equal. So these two sides also equal. All right, so we know that this side over here is also 12.5. Clean that up. And then now, if you know two angles in a triangle, you are blessed because you can find the third one, because you know the total angle in a triangle is 180. So this angle here will be 180 degrees minus 2 times the 52 degrees, because there are 2 of them. What that work out? This is 104. That's what, 76?
76.
Good, 76 degrees. Beautiful. You said what type of triangle it is. If it has 2 equal angles, it's an isosceles triangle.
Isosceles.
Beautiful. Isosceles. All right. It says determine angle PNM at this one up here. So that is this calculation that we just did. So it is equal to 180 degrees minus 2 times 52 degrees. which is 76 degrees. All right, then it says calculate the area. Okay, we're going to calculate the area using the trig formula for the area of a triangle. Half AB sine C. Remember, with a trig formula. So if you have two sides, I'm going to draw it deliberately like this. If you know this side is A, this side is B, and this is angle C, then the area, and this will be angle C because then this side will be C. Remember the angle and the side that are opposite to each other carry the same letter, but the side carries a common letter and the angle carries a capital letter. That's a standard notation for triangles. That's why I can put this as angle C. All right. Right. So the area would be half AB sine of angle C. If you look at this triangle, this is my A and my B, which are equal, and my angle C would be 76 degrees. So the area that I want up here will come a half 12.5, but it's 12.5 times 12.5, right? So I can always try 12.5 squared times the sine of this 76 degree angle between them. Sine of 76 degrees. So this is a calculator piece of job, right? Calculator job. Let's get the calculator and work it out. Anybody did it this way? Anybody
Yes,
did it
sir.
this way? All right. Let's see. 0.5 is a half times 12.5. 12.5 squared times the sine. You should calculate this in degrees. Yes, it is up there, DEG of 76. So you're supposed to get 75.8. 75.8, and it is centimeters, right? Yes, centimeters squared. Centimeters squared. That's my answer. This over here was just a formula. That's to remind us of the formula. This is the actual working for the question. You got that one, right? You got 75.8?
Yes, sir.
Beautiful. 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 All right, let's continue down here. All right, so skipping over this one. Well, this is the reasonable logic. So this question, we could do this question now. We're not skip over it, was not reasonable logic. I didn't give you this one to do, you know. This thing yet, the circles yet. No, we're doing circles in the new year, so forget about that. Yeah, forget about it. We'll do it in the new year. But this is reasonable logic. So I'm gonna do maybe down about February. We'll do that topic. All right, come to number 8. So actually finishing the paper. So you're getting a different paper for tomorrow. All right. So they want us to solve this pair of simultaneous equation. This one is a curve. This one's a line. All right. And when we're solving a line and a curve simultaneously, most times you substitute the line equation into the curve equation. This is a line one. This one is a curve one because I see the y squared there. So I know that's a curve. So because this has x as a subject and this x here as a subject as well, means I can simply take all of this and substitute for the x right there. Substitute the line to the curve for x. Let's say that. So that this is a curve. This is a line. I'm gonna sub for the x, the line into the curve. And so we're gonna get y squared plus 2y plus 11 equals 5 minus 3y. That's a quadratic equation in y. So we're gonna be finding the y values first. All right, I remember you have to transpose everything and leave 0 alone on the right side because you want to set it in the standard form of a quadratic equation. So this is the only y squared term there. This negative 3y comes over, add to that 2y to give me 5y. This 5 comes over and subtract from the 11 to give me 6. 11 minus 5 is 6 equals 0. This one kind of easy to factorize because the only factors of that y squared is y and y. And so I need factors of the 6 that add to the 5. That's clearly 2 and 3. Signs are positive. No, signs are the same. This tells me that 2 signs are the same. This tells me that they are both positive. Positive, positive. And I can check it. This times this gives me the y squared. This times this gives me the 6. Then the 5y is the far product, which is 3y, and near product, which is 2y. 2y. 2y and 3y is 5y. Practice, you'll be able to do it quickly. All right, so this factor, if it is equal to the 0, I'm going to get y equal to negative 2. This factor, if it is equal to the 0, I'm going to get y equal to negative 3. Then I'm not done. I need to find the x value to go with this and the x value to go with that. So I have to substitute them back in the line equation, which already has x as a subject. Makes sense with the easy way. So I can say, and this one, for that one, the x is going to be 5 minus 3 times negative 2. This becomes a positive 6. So the x is going to be 5 plus 6, which is 11. So 1 point is 11 negative 2. And we put the x value first in the bracket. Even though we found the y value first in the solution, you put it second in the bracket. Everything important. Then for this one, I'm going to substitute the negative 3 for the y in there and get x equals 5 minus 3 times negative 3. This minus is a plus 9. 5 and 9 is 14. And so the x becomes 14. And so the second point is 14 negative 3. Those are my 2 points of intersection. That's my solution. Are you okay with that? Any questions?
Yes, sir.
But okay. All right, good. Somebody have a question? Is there any question? No?
This works for every simultaneous.
No, remember, if you get 2 lines, you can use the elimination method as well. You can also use elimination method in sometimes with line and curve, But most times we get a line and a curve to solve simultaneously. You use a substitution method. Usually substitute for one of the variables. Make one of the variables the subject of the line and substitute it in the curve. But you are blessed in this question because they already had x as a subject of the line equation. And so we substitute for the x that is in the curve equation. Right? So generally speaking, you use a substitution method when it's a line and a curve. Right? For the most of them, majority 99% of them, that's the method they use. Substitution. Substitute a line into the curve for one of the variables. All right. This one now is a completing the square. They give us this. I don't want us to write it as that. All right. Remember, they give x plus h. Some teachers teach with the x plus h and k, and they give you a formula for the k, a formula for the h. It's a plus, but as in this class, because they're always changing how this appears on the question paper, we use, instead of that, we use a into x minus xt squared plus yt. Xt is the x value at the turning point. Yt is the y value at the turning point. There's a formula for xt, there's a formula for yt, using the coefficients from the standard form. We write them out. From this standard form, the a is the coefficient of the x squared term, which in this case is 4. The b is the coefficient of the x term. In this case, it is negative 8. It cannot ignore the negative 8. And the c is a constant term in the expression, which is negative 2. And so the xt that we need to go here is minus b over 2a. If you're using the x plus h method, then the h and will be b over 2a. Notice we have a minus xt. And that's why you have this negative on ours and there's no negative on that one. That's where the difference is. All right. So you have to be careful with the method that you're using. Decide on a method and stick to it. But if you understand it clearly, then it doesn't matter which method you decide to use, because you understand it. When we write our turning point, it is xtyt. When you use the h method, then the turning point is minus hk. Has to be a minus hk. That's the difference. All right, so I prefer this way because you don't have to putting in the minus or anything like that. You know, the xt is the x part of the turning point. All right, so the minus b over 2a then becomes minus, that's this minus. The b is negative 8. You can put in a bracket like that, divided by 2 times a, the a is 4. This becomes a positive 8 over positive 8, which is equal to 1. Now, when my xt is a number like this, I can find the yt by substituting it in the original function. You know? Let's do it that way. So yt, if we substitute the 1 for xt in the original function, I'm going to get 4 times 1 squared minus 8 times 1 minus 2, which then becomes, this is a 4, right? This is a 8. Or these two become negative 10. That's right, at negative 10. So become negative 6. The other way to do it is with the formula. Let's do it in red right here. Yt. Yt using the formula is 4ac minus b squared divided by 4a. When the xt is a whole number like that, we don't need to use this method. We just substitute that xt value back in the function to get what the yt value is. But remember, you know, xt, yt are coordinates at the same point. So yt is the y value when the x value is xt. That's why you can substitute the xt value in the original function to get what the yt value is. But this is the other way to do it, right? And some teachers teach k as this formula. It's the same thing. All right. Some people give a modification to say k equals c minus b squared over 4a. It's the same thing. Because if you divide this by the 4a, then we're left with this c right there. All right. So some teachers give this one. So I'm just giving you all these variations. So anyway, let's go to our method, which is yt. So yt becomes 4 times the a, which is 4 times the c, which is negative 2, minus b squared, which is negative 8 squared, divided by 4a, 4 times negative 2. And see how all of this to work down when, because it's a whole number, we got it easily right there. All right, we're supposed to get back 6. So you see, you don't even get a lot of space to work. So yt will be equal, let's show that this is 6. Let's just get a calculator and show that this is also negative 6. I'm just use a calculator and show it. Rather than to be working it down. You just don't like to do mathematics away that is more difficult than it has to be. So it will be 4 times 4 times negative 2. No, wrong thing. 4 times 4 times negative 2. And then minus bracket negative 8 squared. You're dividing that by 4 bracket negative 2. Let's have something here. Times negative 2. Right over. 4 times 4 times. Let's put a -2 in the bracket. 12. Something is wrong. Some a different answer. 4 times 4 times 4AC. 4 times 4 times -2 minus -8 squared over it's a mistake here. 4A. A is not -2. A is 4. Need a 4 here. Need a 4 here. 4. So I need a 4 here. That's it, -6. See, easily using the formula could have made a mistake. So it's -6. All right, so writing the final thing now. Let's write it in purple so that we know the A and everything. Write in purple and say therefore f of x is using this method, not this. The A is 4. Yeah. Bracket x minus xt is 1 squared and plus yt is -6 minus 6. So this thing in purple is the answer right here. Question says to state the minimum value. The minimum value is this yt value. Yt, which is -6. That's the lowest value that function can be. All right. It says determine the equation of axis of symmetry. It is x equals the xt value. That's why I like to use this method. We calculate xt, but then it becomes x equals 1 as the axis of symmetry. But okay with that?
Yes, sir.
Yes, sir.
All right, good. So we don't do this topic yet. This is rate of change. This is about March or so. Rate of change. So we're moving on. I'm gonna do this in January, right after trigs. Right, after elevation and depression, we do bearings already. So we're doing this soon, very soon. Maybe by the second week in January, we're doing this circuit theory. All right, it's gonna be a fun topic. It's a fun topic. Then we're doing this one now. It's our current topic, the last topic that we did, bearings. All right, so this question said diagram below not drawn to scale shows the route of a ship cruising from P, city P, to Quayton Q, P to Q, and then to Riverton R. We're really interested in P, Q, and R. All right. It says the bearing of Q from P. Q from P. P is the from position. From P to Q is 133. And they're helping you. They're putting it on the diagram here. So it's like you stand at the front position, P, you face north first. It's an angle through which you have to turn to the right to face Q. From P to Q. So they're helping you by giving you this 133 there. And the angle PQR is 56. That's the angle inside here. All right. It's that. What I want you to do. I want us to calculate angle W. Angle W, which is this angle here. All right. So if you notice, I kind of mark this one for you, but I didn't put the angle in there. This angle is an easy angle to find because it is co-interior this one. But this line and this line parallel, that join down here with this one. So it's like we are formed over U. U angles, co-interior angles. They are supplementary, meaning that they add up to 180 degrees. These two add to 180 degrees. Angles in the base of the U. All right, call them U angles. They are co-interior angles. And so this angle right here, this one, becomes 180 degrees minus 33 degrees. Minus 133 degrees, sorry. 133 degrees. Nobody did it? Nobody did that?
Yes, sir.
Yes, sir.
All right, good. Now another way you could do it. What is work out? I'm gonna show you another way. What is work out? Minus 31st, you get 150 minus 3, you get 147, right? You get 47, sorry. That's correct? Hello? That's 47, right? And
Yes,
then
sir.
you're gonna
Yes, sir.
see and you're gonna see total angle on a straight line is 180, right? Over here. And so this W angle that I want would be equal to 180 degrees minus the sum of the 56 and the 47. 56 and the 47. I could work it out that way. I'm going to show you another way to do it. Z angles. Now, what is work out to? What it is? I'm going to work out the preferred way down here. What is work out to? I can't tell me that.
Sir, 67 degrees.
67. You sure?
Yes. Yes, sir.
Somebody's got that too? Nobody's got that?
Oh, yeah, hold on. Yeah, I'm pretty sure it's 67.
All right.
No, sir. 77.
Contending views. Now, let me do my quick. Let me do my check. 180 minus 56 and also minus 47. 77. All right, 77. All right, 77. Well, let me show you the way I would prefer to do it though. I could do it without doing this. You could also recognize, let me take this off. You could also recognize the Z in here. This line and this line down here parallel. And they alternate on this line. And so this angle up here is equal to this angle down here. And as in a Z, but like the Z is stretched out. So this total angle is 133 degrees, you know, because it is equal to this one. So if this angle is 133, then the W is equal to 133 minus 56, right? So 133 minus 56, I get the same 77. Now, anybody can tell me why I'm leaving off the degree? I'm not putting the degree on here. And I should have left it off over here as well. Here. If I'm leaving it there, then I have to put the degree on the W over here. W degrees equals 77 degrees. So the W is 77. So am I leaving off the degree here? Let me tell you why. Because the question gave us W degrees. See it right here? So the W is just a value. So you don't put degree on the W. The angle is W degrees. So the W is just a value. So now that we know that the W is 77, it means that the angle is 77 degrees. So the W, that's why the question asks, well, it said the value of angle W, but it's 77. W is just 77. All right? And the angle is 77 degrees. So this is my preferred way though. I did it this way before over here. All right, let's see what else they want. They also want us to determine the bearing of P from Q. So got it. Must always pay attention and note from position. So it's from Q, sorry, to P. So you're doing everything at Q. Q is the from position. So let's look at the diagram and draw that bearing angle. From Q to P. From Q to P. Let me erase this. Erase this. We know the W is 77. But this is the from position. So it is like you at the front position and you face north first. And this is us facing Q this way. So it's an angle through which I have to turn to the right all the way around here in order to face Q. All the way around there. That blue angle. That's the angle that we want. Let me take this off. Move it somewhere else. Move this somewhere else and put it up there. So let's say I call this angle theta. This bearing angle theta. But can tell me how I can work it out. This and for that. This angle I want. This
The
angle to come
total
back.
angle going around is 360. So you got minus the 180 off of that, and you something you can add 56 and 77 to 180, and you're done.
Oh, come again. Say it again.
So once the one side that you don't find yet is going to be 180. So you're going to just
Multiply.
add 56 and W, which is 77, to 180 to get your answer.
Okay. So it's basically saying like you take this blue angle and you break it. Like so. And then from here to here is 180. And then from here to here is the W first 56. That's what you're basically saying, right?
Mm-hmm.
Good. So this is equal to this bearing angle theta is 180 degrees. That's a straight line to here plus this W, which is 77, plus this 56. That gives it a bearing. All right, so we can literally copy this down. Copy this down and work it out. So what you get? Well, these two are up to 33. Remember?
I got 313 degrees.
Yeah.
300 how much?
300.
13.
313. 313. All right, I'm sure another way now. One math equals better maths. Let me show you another way. You could have gotten it. Show you another way. Just now. All right, let's leave that, right? That's the angle that we want. If I extend this line, which is what is here now. Look at this other way. If I extend this line, see this line? This line is forever and ever, amen, on a bearing of 133 degrees. That line. It's on a bearing of 133 degrees. Right? 133 degrees, this line. I want this blue angle. So because this purple line is on a bearing of 133 degrees. Look at this now. Let's put another color. Let's put it in black. I know that right here is 133. And then the rest of it back to the purple line is 180. So we could have added these two as well. See that? But can see that?
Yes, sir.
Yes, sir.
Right, so that's another way you could have done it, right? The purple line is on a bearing of 133 degrees. Anywhere you put the purple line, it's on a bearing of 133 degrees. So this part of it is 133 degrees. And then to complete that blue angle, the purple line back to the purple line. That's 180. So to get that bearing, we could have added these two and get the same thing. Check it for me now. So go to or theta is 133 plus 180, which is what, because these two are the 133 anyway. So to give it a 313, that's the same. So that's another way you could do it, all right? One maths equals better maths. Calculate the distance PR. Let's look at the diagram PR. Let me take these out. What I want the distance PR, which is this distance over here. We're going to use cosine rule because we know this angle in between here is 56. We know this side and this side. So typical case for the cosine rule, two sides and an angle between. All right, let's just write it on the paper on the screen right here and copy it down. Cosine rule. We have to use, let's put this up here. All right, so cosine rule is going to give us that this side, we're going to leave off the square root. So now I'm going to start by saying PR squared equals, start like Pythagoras' theorem. This side squared plus this side squared. 210 squared plus 290 squared. Minus a piece because it is not an hypotenuse, so subtract a piece. We're subtracting 2 times the 210 and the 290, and then taking the cosine of an angle between them, which is the 56 degrees. Shift it up a bit. Put it here. That's a cosine rule. But then we can do it away. We don't bother put the square here. So instead of putting the square there, you remove the square and then drop the square root over everything over the right side like that. Cosine rule. Let me copy it down now. And this is where I prefer for you to do it, save time and space. You don't get a lot of space to do these questions a lot of the time. This is it. I'm going to examine a cosine rule. And then you put this in the calculator and work it out. Put all of this in the calculator and work it out. Let's see. Bang, 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 bang. All right, let's see. So the square root of 210 squared plus 290 squared minus 2 times 210 times 290 times the cost of 56. 245. 245. 3 digits. Everything was in kilometers, I think. That's right. It's kilometers or meters. Let's see. We check the units, right? Kilometers. All right, so that is it. 245 kilometers. Nice and easy. And the question is done. Any questions there? Questions on that? But okay with that one?
Are you supposed to round it or something?
No, you normally give your answer to 3 significant figures. And look, you have to be observant, you know. Look how they give it the distance. They give it nice 3 digits. 3 digits. Give them back with 3 digits. You get this, just give them back the 3 digits. But I put no decimal after that. That is sufficient. But remember, I know, normally we try to give 3 digits. That's 3 digits. Three significant figures. 3 significant figures. This is 3 significant figures. I don't need to put the point. But if you put it neither here nor there, you're gonna lose marks. If you put the point whatever, you put 0.13, you're not gonna lose marks. But the standard is 3 significant figures. When in doubt, give your answer correct to 3 significant figures. All right, 3 significant figures. All right, let's go to this one now, which is our transformation matrices. All right, this question says transformation M, which is this one, it maps R onto R prime as shown in the diagram. All right, so this matrix maps this point onto that point, and they're gonna want us to tell them what transformation it is. All right, let's see. It says determine the value of P and Q. So what it is that the point R is, got it now, it is 2, -5. Let's set it up. 2, -5 is mapped onto, this point is 5, 2. with the matrix 0, P, Q, 0. So, yes. That's what we have now. That's the situation right now. So it means that you multiply this point by this matrix, the result is that matrix. Let's set it up. It means that 0p q0 times the vector for this point, which is 2, negative 5, gives the vector for this point, which is 5, 2. So we have essentially set up an equality of matrices. That's what we have created. So what do we know? Let's look at it. Under the work over here. Let's do it in red. Over here. So this value is obtained by multiplying this row by this column. We can set that up. So we know the 0 times 2 and the 5 times negative, p times negative 5 equals this 5. This row times this column is giving us this 5. So setting up that is 0 times 2 first. First element in the row times the first element in the column, 0 times 2. And then p times negative 5. P times negative 5 is negative 5p. That's right. That's right. Negative 5p is equal to this 5 over here. This is 0 now, so it's have no factor. So if negative 5p equals 5, then p equals negative 1. So the p is negative 1. Now come to the second pair. This 2 is obtained by multiplying this row by this one column. So it is the q times 2 and the 0 times negative 5 that is equal to the 2. So we can set it up again. This row times this column. So it's a q times 2. Q times 2 is 2q. And then the 0 times negative 5 is 0. Again, that's right. 0 times negative 5. That is all equal to this 2 right here. This again is not material in the calculation. If 2q equals 2, then q equals 1. So the q equals 1. So those are my answers. So we know the answers now. Let's write them. We can draw p equals -1, q equals 1. That's my answer. So it means that M is a matrix 0, -1, 1, 0. That is the anticlockwise 90-degree rotation matrix. I know what it is. When you know the matrices, the questions become a lot easier. 90 degrees anticlockwise rotation about the origin. So negative up here. I know it's anticlockwise 90 degrees. See, describe it fully. It's easier to describe when you just know them. Don't waste a lot of time. 3 marks to describe it, you know. Get this 3 mark easily by just knowing the matrix. You don't have to go figuring it out if you know the matrix. So we can just write M is an anticlockwise transformation M we're talking about, you know. Let's call it M, transformation M. Anticlockwise. 90-degree rotation about the origin. That's it. If you don't see this part, you're gonna lose a mark. It's 3 marks for this, you know. Why is it 3 marks? Because you have to give the name on the 3 components. Angle, direction, and the center is the origin. The name of the transformation is rotation. So you give the name and the components. Remember also, guys, that anticlockwise rotation is positive. So we could have said a positive 90-degree rotation. CSEC, you have to give it a mark, especially if you put a plus in front of it. Positive 90-degree rotation. Anticlockwise rotation is positive rotation. Clockwise rotation is negative. So if a rotation is clockwise 90 degrees, Instead of saying clockwise, 90 degree, you could have said minus 90 degree, right? Because the clockwise rotation is negative. CSEC, you have to get your marks. But if in doubt, use clockwise and anti-clockwise. But I've seen questions where they give the positive and the negative. Remember, positive rotation is anti-clockwise. Clockwise rotation is negative. You need to remember that. But there are questions that will test your knowledge of that. There are questions. All right, so let me leave that there. That finishes that. Let's move on. Now come to this vector. I think this is the last question in the paper for tonight, and we'll be done. Yep, end of test. So let's finish strong. All right, let's see. This question says PQR is a parallelogram. PQ is U and a like parallelogram questions. It means that these two sides are equal in length and parallel, and so they are equal vectors. These two sides are equal in length and parallel, so again they are equal vectors. So you fill out all the information on the diagram. So since this vector here, PQ is U, going up this way, means that on this line going up this way, this vector is also U. And since PS is V, going this way, on this line, and this line, which is the same length and parallel, going this way, is also the vector V. Right? So remember, vectors is basically like where you go around the diagram from point to point and trying to travel along these vector directions that you know. Right? I don't know the path across here yet. I can find it out. Right? Which they normally ask you anyway. See here, very first question. It's the vector QS. Where do I go from Q to S without coming across here because I don't know the vector across here? I don't know it. How can I go from Q to S? I can go Q to R this way and then go R to S this way. Nice and easy. So it's V minus U. Why is it minus U? Because I'm going in the opposite direction to U. So go from Q to R, that's a V, and then R to S, that's a minus U. So this is simply V minus U. Keep it simple. This is equal to V minus U. Done. What are you good at that?
Yes, sir.
Could also go minus U plus V. Same thing. Minus U plus V. Same thing. All right. So basically now, it's almost like we now know this road across here. We now know it. I didn't finish reading the question, because they tell us of the point M on this side, such that QM to MS is 1 to 2. QM is this piece. MS is this piece. All right, and then in the ratio 1 to 2. So it is like QM is one part of the line. I'm gonna put the 1 on it. MS is 2 parts of the line. I'm gonna put the 2 on it. So the total parts on the line is 3. And this part of it is 1 out of 3, so it's 1/3 of the entire line. And this is 2/3, 2 out of 3, 2/3 of the entire line. So the M divides the line in the ratio 1 to 2, so you have a 1/3 part and a 2/3 part. This is 1/3 of the whole line, and this is 2/3 of the whole line. All right. So as we said, now we now found QS, so it's as if we now know this road. We now know it. We can now travel across here using this vector, V minus U. So we now know that road. We can now travel across there. All right, we can now use it. If we go from here to here, this is just 1/3 of the whole thing. If we go from here to here, this is 2/3 of the whole thing. Now watch me now. I prefer to travel in this direction because it is consistent with the direction from Q to S. If I travel in a way so that I go against that direction, then I have to introduce the negative. I don't want to have to introduce the negative because I want to do the mathematics the easy way every time. So once I have the option of traveling along this path, this vector line, I want to be going this way. Choose the option that causes me to go that way, right? And if it is just from here to here, it is 1/3 of the whole thing, 1/3 of that. And if I have to go from here to here this way, then it is 2/3 of that. Okay, I know coming all the way across here is this. But the question is going to be set up so that either coming from here to here, or you're going from here to here. But let's see what the next question is. It says we must tell them QM. See, let's just take a piece right here. QM, Q to M. QM is just 1/3 of this whole thing. That's right. It is 1/3. This is 1/3 of the entire QS. This is QS. And so it's 1/3 of this and 1/3 of that. So it becomes 1/3 V minus 1/3 U. All right. Next part. Wants us to calculate or to show that MR is this. MR. Let's look at the diagram. MR. All right. MR is this. So basically, to show that MR is equal to this, we just need to calculate MR and express it as that. That's how we need to do MR. So let's look at going from M to R now. Go from M to R. Easy. Go from M to R. I'm not going to go this way because I'm going in the opposite direction to QS. I prefer come down this way to S first and then go from S up to R. Right? That's how I go from M to R. So let's write it out here. To go from M to R, I'll go M to S and then S and then S to R. Remember, plus means and then. I'm putting on the vectors. Vectors is just basically at this level, how you go from point to point. Right? And then this MS is 2/3 of QS. So instead of MS, I'm going to write 2/3 of QS. So MR becomes 2/3 of QS plus, and then the SR is just this U. I'm going to add the U right here. And 2/3 of QS is 2/3 of this. So then MR becomes 2/3 of the V minus 2/3 U. And then we're adding back this U right here. And so you have a whole U minus 2/3 U. A whole minus 2/3 is 1/3. So MR becomes 2/3 V. A whole U minus 2/3 U is 1/3 U. All right, so this is what we have. We just need to factorize. Let me copy this down now. I'll just do it here because I want to show it in relation to the diagram. I'll cut it. Place it down here. Just want to make sure it's still seeing the screen. All right. And then if you notice, all I did here now was to factorize. I factorize a third to get that. So all I did, factorize a third. So if I factorize the third out of this, a third gone outside here. So I'm left with 2V. And then out of the third is out here. So I'm left with the U. This U over here plus U. We have it all the way around, but it's the same difference. It's the same as a third 2V plus U. Same thing that I have here. Therefore shown. I'm showing it. Right, so the same thing. Then down here now, typical question. T is the midpoint of PQ. Prove that R, M, and T are collinear. They always ask questions like these, right? T is the midpoint of PQ. Let's put on the diagram. Let's put on the diagram and show it. So, right on this side, T is the midpoint. It's like a repeat question. So T is coming right here. So I'm going to divide this U into half and half. So let me erase it. Let me erase the U. Where is it? Where is the white? Draw the white. I had it some time ago. All right. See if I can get it. Good. I'm taking this out. I'm gonna place a dot right here for the T. And so since I move the U, means that from here to here is just a half of U, and from here to here is a half of U. So this vector from here to here is half of U. Let's draw that vector this way. Is half of U, and from here to here is another half of U. This is the point T. We want to show that these 3 points are collinear. Put them on in purple. These 3 points are collinear. That's what I want us to show. If you want this diagram, I can say that, right? 3 points are on a straight line. So to show that 3 points are collinear, to show that there are 2 vectors between the 3 points and a common point. 2 parallel vectors. 2 parallel vectors between the 3 points. 2 parallel vectors. Now remember, we have a vector from M to R already, you know. See there? We just found it. It's this one. I'm going to use that one. I'm going to use this factorized one. I'm going to use this one. All right. We need to have another vector with the T. So we're trying to prove that T, R, M, and T are collinear. We have one vector that we're going to use. Let's write it down. We have one vector we're going to use already. I'm going to use this MR vector. MR equals 2/3 V. I can do 1/3 U first. 1/3 U first. 1/3 U plus the 2/3 V. Don't matter. And we need another vector. Another vector with a T. So if you look at the diagram now, it is either we're going to be using the TM right here, or we're going to be using the TR right here. So the question is, which one is easier to find? The TM or the TR? Anybody can tell me? Is it easier to calculate TM vector or TR vector? Which one is easier to find? Can you use any one of them? We're already using the MR. Huh? The TR. Good. It's easier. TR easier to find. Yes, because you can see it on the diagram. To go from T to R, we go from T to Q first using the half U, and then go across here to V. That's it. So it's half U plus V. Right? That's what we want to use. The TR, the TR, just half U plus V. Based on the diagram, half U plus V takes it from T to R. So this is what we're using. Let's copy it. Let's copy it down and paste it here. All right. And so now we have these 2 vectors. We want to show that they are parallel. We want to show that one is a multiple of the next. There's 3 steps method that we use in class. That's the first step. But can you remind me? That's the first step. Not change. Get rid of the fractions. Get rid of the fractions. Get the fractions out of the vectors because it is more difficult to see the relationship of numbers when they're in fraction form. It's easier to see relationship with numbers when they're whole form. So for example, a third and 4/8. It's kind of difficult to see the relationship between those two numbers as compared to 3 and 9. You know, this multiplies by 3 to go from 3 to 9. When the numbers are whole, it is easier to see the relationship between them as compared to when they are in fraction form. That's why we get rid of fraction first, trying to simplify the thing in a way. We want to show that this equals something times that, some number times that. So we get rid of the fractions first. How do we do with this vector equation to get rid of the fractions? This is what we see there. Multiply by
3
the
for MR.
lowest common multiple of the denominator, right? Which is a 3. This is a 3. So multiply by 3. Multiply by 3, this fraction will be gone and that will be gone. Remember to multiply over this by 3 as well. So we're going to get 3mr equal, multiply this by 3, you get a u. Multiply this by 3, you get 2v. And then to get the fraction of this one, what do we do?
Multiply by 2.
That's all the fraction there, right? Multiply by 2. Multiply this by 2 as well, don't forget. So we get 2tr equals, this becomes a u. Multiply this by 2, we get 2v. And you see that they are now the same, they are now equal. So there no need to adjust. Since they are equal, it means that this is now equal to that. So we can equate the vectors. Equate. We can equate them. So we equate them because both of them is equal to this. It means that we can put that is equal to that. So we can write that and say, therefore, 3mr is equal to 2tr. So this statement means now that they are parallel. It's obvious what the common point is. R is on that vector, R is on that vector. And so we have satisfied the two conditions for collinearity. The first condition is that you must have parallel vectors, which we have. So you're going to state it. MR is parallel, this is a symbol for parallel, to TR, than the vectors.
The other one is that have a common point. Or
common point, state the common point. The second condition is that they must have a common point, which obviously is R. State it. R is a common point. And because you have these two conditions, you can make the conclusion that the points involved are collinear. So therefore, R, M, and T are in fact collinear. They are on a straight line. And you are done. That's it. That is it. Gotta go to that. But okay.
Yes, sir.
Yes, sir.
All right. So remember, guys, did for me, please, and thank you. Those of you who did not do the paper, you need to go and do it still. Use the video to help you. I'm going to share the video right afterwards. The link to the video. Those of you who did it and got anything wrong, you need to redo it. All right. Eliminate the mistakes. Redo the questions. All right. I'm going to send another paper for tomorrow's class. I'm going to send another paper for tomorrow's class. You're going to go back through this one. Go back over what you got wrong. Those of you who did not do it, you need to do it now. And then do the next paper for tomorrow. Remember, moving on to new stuff in January. New stuff when class resumes in January. So you need to master these things that we have covered already. All right. Yes, we're going to have our exam prep in March. We're going to be, going back over all these things using a practice approach, not me teaching them over again from scratch. We're going to go back over them by practicing. but I needed to master them as early as possible. Sooner I master them, the better. All right, so that is the plan. All right, guys, so I'm going to end it now, and I will see you all tomorrow. I'm going to send another paper to the group for you to do. Okay?
Yes, sir.
All right, then. All right, bye. I'm going to end it now. Bye. And I'll send the video right away. All right, guys, bye.
Bye, sir.
Bye.
Cool.